Yes, hello. All right, graph two full periods of a given function. Cosecant is the reciprocal of sine. So we are going to graph y equals 2 sine 1/2 x plus 3. Let's think about those transformations. I see the 1/2, that affects the period, right? So for sine, we always do 2 pi divided by whatever's between the sine and the x. So this will be our period. But when you divide by 1/2, you're really multiplying by 2. Or sorry, yeah, 2 pi times 2. I don't know why I wrote divided by 2 or why that's not erasing. There we go. Sorry about that. 2 pi times 2, which is 4 pi. So one full cycle will happen in 4 pi's. Now, if we're thinking about our steps for that, and we divide by 4, that's going to give us pi for every one of our steps. So that's how I'm going to scale across the x-axis. So I'll make it pi, 2 pi, 3 pi, and 4 pi. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, more pi.
All this pie time is getting me hungry for pie. Apple pie, blueberry pie.
Okay. I also see it that we're shoving this whole graph up 3. We have a vertical translation of 3. 1, 2, 3. Here's going to be the center of our graph. And then the 2 represents the amplitude. So it's going to go up 2, it's going to go down 2 from there. So at most, it's going to come up here to 5. At the lowest, it's going to come down to 1. So we're doing sine, which means starts in the center. So we're starting right at 3. And at pi, it'll go up to 5, 2 pi, back down to 3, 3 pi, to 1, and 4 pi, back to that center. Woo! If we took it back the other direction, negative pi will be at 1, negative 2 pi back at 3, negative 3 pi at 5, negative 4 pi back at 3. So this would be the graph for 2 times sine 1/2 x plus 3. But remember, we are doing cosecant. So every time our graph is at the center line, which technically is at 3 for this one, that becomes a vertical asymptote because that's where it would work out to equal 0. And then if you were to take the reciprocal, it'd be whatever divided by 0, which is undefined. So you can't have that. So those are our asymptotes. And then invert your parabolas, man. At 3 pi, we're at 1. But remember, we're going to have a parabola going off of that. So it'll go down towards the floor. Now at pi, we're up here at 5. And then it would go off the graph vertically. But we can kind of imagine how that would look. At negative pi, it's going to go down from there. Woo! Woo! And at negative 3 pi, we're maxed out, so it'll curl up from there. There we go. That wasn't so bad at all, was it?